Welcome to the third live session of the course Solar Energy Engineering and Technology. So in this session, primarily, I'll be summarizing what are the contents covered from Module 9 to Module 12. So in Module 9, we have extensively discussed about solar air heaters. In Module 10, solar concentrating collectors were discussed and compared its performance. Thermal energy storage were discussed in Module 11, and in Module 12, emerging solar energy technologies were discussed. So in Lecture 1 of Module 9, primarily we have discussed about fundamentals of solar air heaters, performance analysis of solar air heaters, and different types of solar air heaters and its importance. In Lecture 2 of Module 9, solar testing, that means testing of solar air heaters, were discussed, and its applications in drying of agricultural products, under drying of agricultural products. We have studied drying characteristics curve, drying calculation, and then process heat in industries, what are requirements, how this kind of device can be suggested for process industries were discussed, and at the end, how these systems can be applied for power generations were elaborated. As far as testing is concerned, normally if we buy a solar air heater, we placed in a experimental setup, and then we fix these thermocouple sensors to monitor the temperatures here at the inlet, and at the outlet we have mixing vents so that we get the uniform temperatures, and here we have to characterize the solar air heater. In Lecture 1 of Module 10, concentrating solar collectors were discussed. Primarily, in this lecture, fundamentals and classifications of solar concentrating collectors were discussed. So if we have to concentrate on classifications, this can be classified based on the reflecting type, utilizing mirrors, the refracting type, utilizing Fresnel lens, imaging, it may be line focus system or it may be point focus system, concentration ratio. That means we can say that it is nothing but operating temperature and tracking. And also we have studied basic energy balance equation and the analysis of parabolic trough collector and heat transfer. So as you can see, this is a schematic of a parabolic trough collector. So here this is the header, and fluid goes through this tube, and this is placed at the center, and then reflected radiation, solar radiation falls on this concentrator, and then it is reflected to this absorber, through which heat transfer fluid flows. And finally, we can store the heat in the heat transfer fluid, and that can be transferred to the working fluid if we use a Rankine cycle for power generation. Otherwise, we can use this heat for thermal application. And as far as energy balance is concerned, so we can have useful heat gain by using this expression. QU is equal to AA multiplication of S minus UL by C whole TPM minus TA. And also we know what is CA, which is the concentration ratio, which is defined as effective aperture area to the observer area. So finally we can calculate the concentration ratio for a particular concentrator. In Lecture 2 of Module 10, concentrating collectors, technologies and working principles were discussed. Also we have compared the concentrating collectors, like power towers and troughs are best suited for large grid-connected power projects in the range of 30 to 200 megawatt. These engine systems are modular and can be used in single-dish applications for grouped in these pumps to create large multi-megawatt projects. Parabolic trough plants are the most mature solar power technology available today. Power towers with low cost and efficient thermal storage promise to offer dispensable high capacity factor solar only power plants in the near futures. So these were elaborated in this lecture. In lecture 1 of module 11, primarily sensible heat storage system, latent heat energy storage system, and thermochemical energy storage systems were discussed. In lecture 2 of module 11, we have discussed solar ponds, which is nothing but salt gradient solar pond. And in this lecture, we have discussed the fundamentals and working principle of solar ponds and how this temperature variation takes place, and also the energy balance, and what are the shortcomings while it is in operation, then what are different types of ponds, and then its applications, which were elaborated. In lecture 1 of module 12, emerging solar energy technologies like perovskite solar cells, organic solar cells, dye-sensitized solar cells, quantum dot solar cells were discussed. And also at the end, photovoltaic thermal technology were introduced and discussed. In lecture 2 of module 12, primarily we have discussed the applications like how this solar energy can be applied in solar distillation, for cooking, for refrigeration and air conditioning systems, for space heating and cooling, and solar thermal device for low, medium, and high temperature applications. So what are devices we can use based on the requirement? Like if the requirement is for low temperature, then what device will be suitable? If it is for medium, then what device will be suitable? And then if the temperature is requirement is high, then which device is prescribable? So these things were elaborated in this lecture. So now I would like to thank you very much for your attention. And if you have any queries, then please ask. I'll be happy to answer. In one of the queries which is mentioned in the discussion forum is something like question was to how we can remember the complex long formula for various chapters. What type of questions will be asked in the questions in the computerized exam? So see here, though you don't have to worry about the formulas. So long formulas will be provided in the question paper, and mostly these are MCQ type of questions. The kind of questions we have already asked in the assignments. So similar kind of questions will be asked in the exam. So you don't have to remember all those long expression. For your information, all the solutions of assignments were uploaded in the portal. So You can have a look. Your question is something like when you will get the admit cards. I think NPTEL will send the admit cards to you, like a hall entry tickets. You don't have to worry about it. Please ask if you have any queries. Others I'll leave in 10 minutes. So your question is like.
Good afternoon, sir.
Yes, please.
Yeah, sir. For examination point of view, sir, I want to ask something, sir.
Yeah.
Yeah, sir. So some big correlations are there, sir, in the course module. We have to learn those correlations, or those values will be provided in the exam questions.
Yes. Don't worry about those correlations. No, all the expressions are required to be provided to you, but you need to do the calculation.
Okay, sir. Thank you, sir. Thank you. Sir, one more question is there, sir.
Yes, please.
Excuse me. Yes. Sir, actually, sir, I want to ask that suppose in on-grid connected solar system, if the our connected batteries, suppose they are got charged, and if there is suppose our batteries are overcharged and now our system is still connected is still connected with the uh, सर मैं पूछना चाह रहा हूँ सर मतलब कि मेरा बैटरीज अगर पूरा चार्ज हो चुकी है सर उसके बाद भी अगर मेरा सिस्टम अभी ग्रिड में कनेक्टेड नहीं है तो उसके बाद अगर मेरा एक्सेस जो जनरेशन है सर अगर उसको कुछ कंट्रोल करने का कुछ मेथड रहता है सर
I missed your no question because there is internet issue. Please say again.
Sir, is there any methodology to control the generation? Suppose our connected batteries are got fully charged and the panels are generating the voltage. The batteries got fully charged and the connected systems, the load is not that much capacity. Suppose the load is connected load is only 1 kilowatt and panels are generating much higher than that and batteries got already that amount of charged. Then access to control that load. Like, is there any methodology, sir?
Hello. Hello. Can you hear my voice?
Yes, sir. You are audible, sir.
Yeah. See, now what happens if you are generating excess energy? Then you need some kind of storage device. Otherwise, no, it will be unutilized.
Yes, sir.
Hello. So this queries were something like, no, if generation is more than the load, then we need an effective energy storage system. Okay. So that may be thought of, right? So there was some issues with the connectivity. So there is a question like, now how PV cell size are characterized. So see, now earlier cells were circular in shape, and now in most of the cases we have rectangular PV cells. So this is because to optimize the space, right? Earlier we had a lot of unutilized spaces, and that's how no efficiency of the module were less. So now we try to accommodate more number of cells in a particular area. So that's how we can get the high no efficiency of the modules, right? And all the sizes and other characteristics were elaborated in the lecture videos. Please refer to that. So it's a circular solar cell. That's the meaning of 100 diameter solar cell. It's something like a circular solar cell. So that's what I said. In modern times, most of the solar cells are of rectangular in size. So 1 inch is 2.54 centimeter. So if you say 2.54 multiplied 4, it is 10 and 10 centimeter. And if you say it's a 10 multiplied by 10, it will be 100 mm. So that's how it is 100 mm. So I'll be concluding this in 5 minutes. If you have any questions, please. Okay, then now I'm concluding this video here, and I wish you all the best, and thank you for choosing this course. And in the exam, mostly MCQ kind of questions to be asked, and you don't have to worry much about the big expression what is used for solving the numerical problems. So if I've asked these long questions and long expressions which are required to solve a problem, which will be provided in the question paper. So thank you very much once again.